Now it is your turn to completely factor the polynomial 8n squared plus 14n plus 3. If you have not attempted this exercise on your own already, please return to your lecture notes, complete this on your own, then return to the video to check your work. So we want to factor the polynomial 8n squared plus 14n plus 3. The first step in factoring any polynomial is to look for and factor out the greatest common factor. In this particular example, there is no common variable to every term, and when we look at the coefficients, 8, 14, and 3, the only common factor between 8, 14, and 3 is a 1. So in terms of factoring out a greatest common factor, there is nothing that we need to do. Now looking at what remains, we have a trinomial, and not only is it a trinomial, but its leading coefficient is not 1. Because this is not a 1n squared, but instead an 8n squared, we're going to choose to use the AC method. The AC method begins with taking the leading coefficient and the constant term, so our A and our C values, 8 and 3, and multiplying them. 8 times 3 is 24. We're then going to look for factors of AC that add to make B. In this case, we're looking for factors of 24 that add to make 14. Our next step will be to build the table of factor pairs of 24. One column will have the factor pairs of 24, the other column will have the sum of those factor pairs, because we're looking for a pair of numbers that multiplies to make 24 and adds to make 14. Before we start looking for the factor pairs of 24, we will pause and think about the signs. Since the pair of factors has to multiply to make a positive 24, we know the two numbers will be the same sign, either both positive or both negative. Because they have to add to make a positive 14, we know that both the numbers have to be positive. So the factor pairs that we're going to be looking for are two positive numbers. So things that multiply to make 24, 1 and 24. 1 plus 24 is 25. So while we have two numbers that multiply to make 24, they don't add to make 14. The next factor pair I would come up with is 2 and 12. 2 times 12 is 24, and 2 plus 12 is 14. And so right there we have the factor pair that we're looking for. We will use this factor pair by taking that middle term, that 14n, and splitting it up. We will split it up into 2n and a 12n. So our trinomial 8n squared plus 14n plus 3 will transform into 8n squared plus 2n plus 12n plus 3. And now that we've transformed this trinomial into something larger, the only option we have for factoring is by grouping. So we will group the first two terms together, 8n squared plus 2n. We will group the last two terms together, 12n plus 3, and we will make sure there is explicitly addition between the two groups. When we look at the front group, 8n squared plus 2n, there is a common factor of 2n. And if we factor 2n out of that group, we will be left with 4n plus 1. In the back group, we have 12n plus 3. There is a common factor of 3. And if we factor 3 out of 12n plus 3, we will be left with 4n plus 1. We know we're on the right track if each group individually had its own common factor, and then between the two groups, there again is a common factor, in this case, 4n plus 1. So if we factor 4n plus 1 off of each of those two terms, we will be left with 2n plus 3. So our factored version of 8n squared plus 14n plus 3 is the quantity 4n plus 1 times the quantity 2n plus 3.